For any two objects in space, a line can be extended from the first through the second. The latter object will block some amount of light being emitted by the former, creating a region of shadow around the axis of the line. Typically these objects are moving with respect to each other and their surroundings, so the resulting shadow will sweep through a region of space, only passing through any particular location in the region for a fixed interval of time. As viewed from such a location, this shadowing event is known as an eclipse. Typically the cross-section of the objects involved in an astronomical eclipse is roughly disc-shaped. The region of an object's shadow during an eclipse is divided into three parts. Quote, the umbra, Latin for shadow, within which the object completely covers the light source. For the sun, this light source is the photosphere. The antumbra, from Latin ante, before, in front of, plus umbra, extending beyond the tip of the umbra, within which the object is completely in front of the light source but too small to completely cover it. The penumbra, from the Latin pene, almost, nearly, plus umbra, within which the object is only partially in front of the light source. A total eclipse occurs when the observer is within the umbra, an annular eclipse when the observer is within the antumbra, and a partial eclipse when the observer is within the penumbra. During a lunar eclipse only the umbra and penumbra are applicable, because the antumbra of the Sun-Earth system lies far beyond the Moon. Analogously, Earth's apparent diameter from the viewpoint of the Moon is nearly 4 times that of the Sun and thus cannot produce an annular eclipse. The same terms may be used analogously in describing other eclipses, e.g., the antumbra of Deimos crossing Mars, or Phobos entering Mars penumbra. The first contact occurs when the eclipsing object's disk first starts to impinge on the light source. Second contact is when the disk moves completely within the light source. Third contact when it starts to move out of the light. And fourth or last contact when it finally leaves the light source's disk entirely. For spherical bodies, when the occulting object is smaller than the star, the length, L, of the umbra's cone-shaped shadow is given by, quote, L equals R dot operator R O R S minus R O display style L equals frac R C dotr underscore O R underscore S R underscore O, where Rs is the radius of the star, RO is the occulting object's radius, and R is the distance from the star to the occulting object. For Earth, on average L is equal to 1,384 times 106 kilometers, which is much larger than the Moon's semi-major axis of 3,844 times 105 kilometers. Hence the umbral cone of the Earth can completely envelop the Moon during a lunar eclipse, if the occulting object has an atmosphere. However, some of the luminosity of the star can be refracted into the volume of the umbra. This occurs, for example, during an eclipse of the Moon by the Earth, producing a faint, ruddy illumination of the Moon even at totality. Quote, on Earth, the shadow cast during an eclipse moves very approximately at 1 km per sec. This depends on the location of the shadow on the Earth and the angle in which it is moving.